Hey everyone, welcome back to our Calculus 3 class notes. I have a quick set of one page of notes for section 15.3 in our chapter 15. So the only point I'm trying to get across out of this section is that we actually can find the area between curves using double integration, or understand that what it means if I just integrated one dA, right? If I'm integrating a function of z equals 1, then I'm finding the volume under the surface z equals 1, which is simply the plane that's parallel to the xy plane with a height of 1. Then when I do that, if I find the area of the base times the height 1, so that in other words the area of the base is the same as the volume, right? So when we integrate, and we're just integrating dA over the region R, we're actually finding the area of that region R. Of course, we learned how to do this in Calc 1 by just saying take the integral with respect to x of this function minus the integral with respect to x of this function, and essentially that's exactly what happens when you evaluate the double integral though. So for example, if I want to find the area of the region R bounded by y equals x plus 2 and y equals x squared, so I'm going to draw my region R first. So here is y equals x plus 2, here is y equals x squared, so I need to figure out what points these intersect at. So I'm going to set x squared equal to x plus 2, and I solve for that, and I see that x equals minus 1 and 2. So when x equals minus 1 and x equals 2, these guys intersect. So that's the easiest way to set up my double integral. I'll set it up as dy dx. So my outside integral goes from minus 1 to 2 with respect to x. And then the inside integral, y as x is going from minus 1 to 2, y is going from the function x squared up to the function x plus 2. So you can set it up just like that. So then what happens is when you integrate it, the first integral is with respect to y, so 1 dy, the integral of that is y, evaluated from y equals x squared to y equals x plus 2 using the fundamental theorem. So it becomes x plus 2 minus x squared. And then the integral now is with respect to x from minus 1 to 2. Now this is exactly how you would have set it up back in very beginnings of Calc 2, right? When you're talking about the area between two curves. All right, so this is how you would have set that up with a single integral. I'm just showing you how it could have been set up with a double integral now that we understand what double integrals are. All right, that becomes very simple to integrate. So if you integrate that, you get x squared over 2 plus 2x minus x cubed over 3 evaluated from x equals minus 1 to x equals 2 using the fundamental theorem. Simplifying, you get 9 halves.